All right, welcome back. Let's write another question. Drop my mic there. So this time, let's try a calculated type question, and let's do something with fractions, because surprisingly, arithmetic stuff tends to be one of the harder things to write. So let's do a problem with maybe adding fractions. And and let's be more specific here, because just adding fractions isn't very interesting. So let's maybe add two fractions where, or let's see. I always struggle to figure out a good way to describe these things. Uh, so I'm going to say it this way. So we're going to add two fractions where the denominators have a common factor. Yeah, that's one way to describe it. Okay, so the question type here is going to be a calculated number because the students are going to be entering a fraction in the end. So now, it's worth noting that calculated types have, again, the only required variable is an answer, but the optional variables are really important here. The first is answer format. So this lets you say, I want the answer to be restricted in what kind of answer it is. Because by default, they could put in anything, which means they could just retype the original problem and get it right. So we want to restrict it here. So we could either restrict it to just any old fraction or a reduced fraction. We could allow mixed numbers. And there's a lot of other options here for things like no decimal, if you want to make sure that they're not putting in a decimal answer. No trig, if you want to make sure they're not putting a sine or a cosine in the answer. No value, if you don't want to display them the value, which happens automatically with reduced fraction. So we're going to go ahead and use answer format equals reduced fraction here. And I think that that's going to be a good choice. And then we don't really need to worry about tolerances, decimals, things like that. Again, we could use required times to restrict the format, but because we're using reduced fraction, I think we're okay. And I think that's the only option we really need to set here. Okay, so we need to pick some values. So we need in the denominator, we need these values a, b, and f. So we're going to pick a, b, and f. Now what I really want is for these three values to all be prime, I think. Yeah, prime? Yeah, sure, let's make them all prime. I think that's going to be easiest. I mean, we can make this more complicated by allowing b or f to be not prime. Okay, sure, let's do that. Okay, so let's let's go ahead and pick A, and I don't want A to be too big, so maybe we'll make A a random value between like 2 and maybe like 5. And then B and F are going to be two different random values. Again, maybe between like 2 and oh, I don't really want anything much bigger than like let's see, 5 times 8 is like 40. That's not too bad. Okay, so we'll pick like two different random values between 2 and 8. Now, I really don't. I want a to be the biggest common factor though in each of the denominators. I don't want something bigger than something between 2 and 5, which means I need b and f to both be relatively prime. And so to do that, I can add a condition onto this assignment, and I can do that using the where clause. So this is saying, do this assignment where some condition applies. And in this case, the condition I want to put on is that the GCD, the greatest common divisor of b and f, is 1. In other words, that they are relatively prime. Now, a couple good things to note here. One, GCD, greatest common divisor, handy function to know, takes 2 inputs. Second thing, notice this double equal sign here. A single equal sign is used for assignment. A double equal sign is used for comparison. So this says, is equal to 1. You can also, of course, use greater than, or less than or equal to, or greater than or equal to, or not equal to, which is exclamation point equals. But in this case, we want equals 1. Okay, so our greatest common divisor, B and F, is 1, which means it is relatively, the two values will be relatively prime. That makes me happy. Great. And so now we can continue on with the rest of our problems. So now we need our numerators. So I'm going to pick C, which is going to be a random number between, say, 1... Oh, actually, let's go ahead and multiply my denominator. So I'm going to multiply these two values here, and I'll call it denominator 1. Denominator 1 is A times B. Notice I can just do basic calculations here with things. So my denominator 2 is A times F. My first numerator is going to be somewhere between 1 and d1 minus 1, because I want it to be a proper fraction. And again, I'm going to say where GCD of C and d1 is 1 to make sure that my numerator is relatively prime, so it can't just reduce itself right away. Okay, and now we're going to do the same thing, basically, to pick my second denominator, d, except make it relatively prime with d2. Great, so now I've got my numerator, my fractions built. Now I need to define my answer. Now, if I put this in as a calculation, so if I put it in as C over d1 plus d over d2, then the answer is going to get assigned a numerical value, a decimal value. And depending upon what kind of decimal value it is, the system may or may not figure out that what fraction it is, but only because we're doing a reduced fraction. If this was any other answer format, it wouldn't even try to convert it to a fraction. So if you really want it to display as a fraction, then we're going to have to do a little bit of extra work here. So we're going to have to use one of our handy little functions for formatting. Should be under our format macros here. We should have, here we are, make reduced fraction. So make reduced fraction takes a numerator and a denominator and makes a fraction, reduces it down, and then makes a string representation of that fraction. Very handy whenever you have a numerator and denominator and want to make a reduced fraction out of it. So we're going to, instead of doing that calculation, we're going to say make reduced fraction. And now we're going to actually have to do some math here. If I was going to add these two things together, my numerator would be C times D2 plus D times D1, and my denominator would be D1 times D2. And this may or may not reduce, but that's why we're feeding it into this make reduced fraction function, is it's going to do the work for us of seeing if it actually reduces. Again, notice comma here, not divided by. We're feeding it the numerator, denominator as two parameters. Cool. So now we just need to write our question. So we're going to say add and simplify. And then again, remember those backticks or grave symbols tell it, make this look like math. Our first fraction was C over D1. Our second fraction was D over D2. And this time we're just going to let it put in the answer box all by itself instead of specifying it. Let's go ahead and give that a try. Let me reduce that down and bring it in. There we go. So 16/21 plus, and that is proper, Let's double check it. 42 does look like the lowest common denominator there, and so it looks pretty good. Now notice here that we are getting a improper fraction as the result. And because we told it to do reduced fraction, it's not turning it into a mixed number or anything like that. If we wanted to deal with mixed numbers here, we would have to do some more work. If we wanted to avoid having mixed numbers, we would have to do some more work. Improper fractions. So let's see how we could do that. So there's a couple ways that we could handle forcing the result to end up being proper. Now, I'm going to show you two ways, one of which is good, one of which is not quite as good. So the sort of easy way to do this, but not necessarily good way to do this, is to say, I'm going to create a code block. So I'm going to use braces here, and I'm going to go ahead and use some spaces here to indicate what's going on. And what these braces do is say, I'm going to treat this entire block of code as one sort of combined set of operations. And now I'm going to add a where clause to that sort of block. So I'm going to say where, and I'm just going to say where this numerator is less than this denominator. Now what this will do is it's going to pick the two numerator values, and if they don't satisfy this condition, it will pick the two numerator values again. The downside here is that this is kind of inefficient, because it's going to end up having to keep on picking values until it eventually reaches that condition. Luckily, there's a fairly good probability of it happening. So it's not too worrisome that we're doing this. The alternative would be to limit the range of values that we pick here. We could pick both numerators to be, let's say, less than half of the denominator, and then we'd be guaranteed to have the result come out right. That's a good thing to keep in mind when you're writing questions, is that working backwards is often helpful, and thinking about how can I restrict the randomizers to just sort of work out in the first place is a little bit better, especially with things like quadratic formula, you know, to make sure that you're picking values that have real roots, for example. Okay, so let's go ahead and give this a try, though. So if we give this a try, now we're going to end up with a proper fraction, and a proper fraction, and a proper fraction. And it looks like we're doing better here with sort of what our goal was. So I'm noticing that some of these numbers are pretty huge. Well, I guess that's okay. Alrighty, so there's another example of writing a question, in this case a fraction question. Good things you learned in this one: make reduced fraction, using the GCD and the where clause to force conditions, and creating code blocks here for blocking in a set of code. Alrighty, we'll try another question.